Okay, we are on factoring trinomials notes. It's our first section in our chapter 5. Factoring could take a whole month in and of itself, but it is a review from Algebra 1. So if you're going to struggle with this, we're only going to spend a couple of days on it. So if you find yourself struggling, you need to get extra help. Go on the web and see if you can find some tutorials on how to do it. Ask me. I can give you at least 5 different ways to factor. But the very important thing is that you understand the questions to ask. And to ask the right questions about a trinomial, you need to let the problem speak to you. If I first begin, a trinomial, of course, has 3 terms. So the first one I'm going to talk about is ax squared plus bx plus c. And when I talk about the last sign of the trinomial, I'm referring to this right here, the last sign. Okay, and this one ends in a plus sign. If the last sign of the trinomial is a plus, then the signs of the factors are the same. Now, I do not mean these are the same. I mean the signs of the factors. And the signs of the factors would be like x plus and x plus. These signs are the same. And that would be this case. But if you've got ax squared minus bx plus c, then it still ends in a plus, so they're the same. But in this case, they'd both be minuses. They would both be minuses. So the last sign tells me if signs are the same. The middle sign tells me what they are. So signs are the same and they're both positive. Signs are the same and they're both negative. Now, if we end in a minus, if the last sign of the trinomial is a minus, then the signs of the factors are different. One's plus and one's minus. And I really dependent upon the middle one, we'll talk about that. But again, if it ends in a minus, then that means that the factors have different signs. Okay? And you'll do enough of them that you'll get the hang of it. And if you don't, ask me. We'll have a conversation about it, about specific problems, and I'll test you on what I mean by the last sign. Alright, factoring a trinomial, we're going to look at with coefficient 1. These are the very easiest, and they will help us build a foundation for using coefficients other than 1. And what I mean by coefficient 1 is I mean in front of the x squared there is no number. Okay, x squared plus 12x plus 35. Looking at the last sign of the trinomial, it ends in a plus sign. So that tells me that signs are the same. The middle sign is what they are, so I say signs are the same, they're both positive. So I automatically know that I'm going to have an x plus and an x plus. No matter what method you use to factor, you cannot have the factoring done without the following question. No matter what method you use, if you like a way your teacher told you before, I can show you Punnett squares, I can show you diamond boxes, I can show you factoring by grouping, but I'm going to show you one method. Again, you cannot use any of those methods without the following question. You need to ask yourself what multiplies to give you one number and adds to give you another number. So where do I get that question from? I'm going to take the coefficient, and in the first set, we just got coefficient 1, but I want you to get in the habit of it. You multiply your outer numbers. So I did 1, which is the coefficient of x squared, times 35, and that's 35. So I say what multiplies to give me positive 35, but adds to give me my middle number, 12. So it multiplies to give me positive 25, but adds to give me 12. Again, signs are the same, and they're both positive. So what I would do is I would list out every number that multiplies to give me 35. 1 and 35. 2 doesn't divide, 3 doesn't divide, 4 doesn't divide. 5 is my next number, times 7. 6 doesn't divide, and then I'm already back to 7. So which of these two add to give me 12? So 5 and 7. And that's where my factors are going to come from. So x plus 5, x plus 7. Okay, again, you multiply your outer ones. So it multiplies to give me 35 and adds to give me 12. And you go through the list. Sometimes you'll know them right off, and sometimes you'll need to write the whole list down. So 5 and 7. And if I were to FOIL this, it would be exactly this. All right, example 2. Again, I ask myself what multiplies to give me and adds to give me. What multiplies to give me 21, but adds to give me negative 22. Signs are the same, and they are both negative. So it multiplies to give me 21 and adds to give me negative 22. A lot of people forget about this factors, but to be bigger than that number, you had to have come from a higher number, and that would be my very first one, 1 and 21. But, again, signs are the same and they're both negative. There are my factors, x minus 1, x minus 21. Example 3, what multiplies to give me negative 7, but adds to give me positive 6. Signs are different in this case. So I'm going to have 1 plus and 1 minus. Signs are different. Now this tells me I have more positive numbers. So that means the bigger number will get the positive between the two. So it multiplies to give me 7, 1 and 7. I need to make a positive 6 out of it. Again, that's going to make that a positive 7 and a negative 1. So when I put them in, I'm going to put plus 7 minus 1. Now, here's something very critical. Here is another option to write this same thing. You can write it as x minus 1 times x plus 7. What you cannot right is x minus 7, x plus 1. You cannot do that. You can change the order of the parentheses, but you cannot change the order of which one gets the negative and which one gets the positive. Do you understand? Okay, take just a minute and finish up all of those with coefficient 1. That's going to give you 4, 5, and 6 to do on your own. Go ahead and pause the video and try them. Okay, so the question for example 4 is what multiplies to give me negative 40 but adds to give me positive 3. So multiplies to give me negative 40, adds to give me positive 3. Signs are different. That means I'm going to have a plus sign and a minus sign, different in my factors, okay? Again, I do not mean that these signs are different. I mean that the signs of my factors are going to be different. So I go through. If you don't know it automatically, go through the whole list of 40, what multiplies to give you 40. Just divide it by 1, by 2, by 3, by 4 until it has to be a whole number. So if it goes evenly, then you write them down. And when I did that, I got positive 8 and negative 5. So again, I can say x minus 5, x plus 8, or if you have x plus 8, x minus 5, that is also correct. Example 5, you say what multiplies to give me negative 42, but adds to give me negative 1. Be careful, that is a coefficient of negative 1. Again, signs are going to be different. So I got 6 and 7 being the ones that are close enough to make 1. And the sign of the larger one is negative, and that one is positive. So I get x plus 6, x minus 7. And if you didn't know that, just write down all the factors, give the negative to the larger side, and you would come up with those two. In example 6, so I say what multiplies to give me negative 30, but adds to give me 13, positive. Signs are going to be different. So I'll go through and I'll show you how you do the whole list. So 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into it, and then 5 times 6. Now, a lot of you are looking at this and saying, oh, look, 13, 3 and 10. 3 and 10 is not my answer because signs are going to be different and the larger number gets the positive. Well, this is my whole row of larger numbers. So let me make all of these my positives and make all of these my negatives. And let's see what the sum winds up being. Well, here I get 29. That's not what I need. Here I get positive 13. Oh, that's what I needed. But in this one, which is one y'all probably would have picked, the 3 and the 10, I get 7 out of that. And then, of course, this one is 1. So this is the one that I need, not the 3 and the 10. Okay, so I get x minus 2, x plus 15. So hopefully you got that one right. If you pick the 3 and the 10, do you understand why it is not that one? And now you won't make that mistake? Be sure to ask if you don't understand that question. Okay. Okay, example 7, and I've got a whole lot of examples to do with you, so hopefully you'll get the hang of it. What if the coefficient is not 1? In this case, my coefficient is a 2. Well, here's a new way that you may or may not have been taught, and it's a pretty common way we teach it around at Bolton, so pay attention, please. The first thing you want to do is go through the same process with all the other problems that you've been doing. Except this time I have something besides a 1. I don't just jump to that back number and say what multiplies to give me. So what multiplies to give me 10, but adds to give me 7. Okay? Signs are the same and they're both positive. Well, at this point, you're comfortable enough that you're saying to get 7 from 10, that means it definitely came from a 2 and a 5. So you're going to write down x plus 2, x plus 5. But that is not my answer. Because if I were to FOIL that, there's no way I could come up with a 2x squared. So we have this trick where what we do is we take and we divide by that very first number. Because it has coefficient other than 1, we divide both the factors by that number. You're going to divide and reduce. If it can't be reduced, you leave it, and I'll show you what you do. What is 2 divided by 2? Okay, so that reduces to be a 1. So that factor is x plus 1. What's going on with this one? Well, 5 divided by 2 cannot be reduced. So like I said, I'm going to leave it as 5 over 2. But in the end, I don't want any fractions in my final answer. So any bottom number, I'm going to swing up and put it as the coefficient there. So in the end, I wind up with x plus 1 times 2x plus 5. And that's my final answer. You can FOIL it to check. So that would be 2x squared plus 5x plus 2x plus 5. And 5x plus 2x equals 7x. Okay, example 8. Make sure you're asking yourself the right question. What multiplies to give me what? 36. In this case, it's a negative 36. But adds to give me a positive 5. What can you tell me about the signs? The signs of the factors are different, and you have more positives. So signs of the factors are different, and you have more positives. So I'll go through. Again, if you don't know, it'd be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. That's an exhaustive list. That's going through every last number that'll give me 36. Again, signs are different, so I'm going to have a negative column and a positive column. And how do I know which one gets the negative? Well, in this case, I want a plus sign in the end, so that means the bigger number is positive. And this is my bigger set over here. So those are all positive, which means these are all negative. And which one of those pairs will give me a positive 5? Okay? This is the only one that will give me a positive 5. So that's where I start. So I put x minus 4, x plus 9. And I'm done, right? No, I'm not finished. What do we have to do since I have a number other than 1 in front of x squared? I need to divide that out. So since there's a 6 in front of x squared, I'm going to take and divide both the factors by 6. I need to reduce. If you can't reduce 4/6 in your head, please feel free to use a calculator to reduce that fraction. But I notice that I can reduce them both by 2. And if I take a factor of 2 out of 4, I get 2. If I take a factor of 2 out of 6, I get 3. That reduces that. Now, 9 over 6 reduces. Take a factor of 3 out, I'm left with 3. Take a factor of 3 out, I'm left with 2. That's what reduces. That's not my answer. Anything that's left on the bottom, I want to swing them to the front and put them as coefficients of x. So in the end, my factors are 3x minus 2 times 2x plus 3. And that is my final answer on that one. Again, feel free to FOIL it. So it's going to be 6x squared plus 9x minus 4x minus 6. And that's what we wanted. Okay, example 9. What multiplies to give you negative 40, but adds to give you negative 6? Okay. So I know that the numbers that give me 40 are going to be 4 and 10. How do I know which one gets the negative? So signs are different. You have more negatives. So that means the bigger number gets the minus and the smaller number gets the plus. So I write down x plus 4, x minus 5, minus 10, x plus 4, x minus 10. And now I divide by 5 because I have a number other than 1 in front of x squared. 4/5 is already reduced, so I know automatically that I need to swing the 5 up. So I get 5x plus 4. 10 divided by 5 reduces, so I get x minus 2. Okay, I got a whole lot more to show you, but if you will pause the video and try to work the next ones by yourself, then I'll show you how to do those quickly. So example 10. What multiplies to give you 36, but adds to give you negative 12? So I'm going to come up with negative 6 and negative 6. So I get x minus 6, x minus 6. And I'm not finished. I need to divide by 9. And once I reduce, 6/9 reduces to 2/3. And again, I won't leave it that way. I'll go ahead and swing the 3's up front. 3x minus 2 times 3x minus 2. And if you'll notice, these are the exact same factors. So in the end, what we'll do is we'll write 3x minus 2 squared. And that's our final answer on 10. Number 11. What multiplies to give me negative 40, but adds to give me negative 3. So I just know them. Go through the list if you need to. I know it is 5 and negative 8. So x plus 5, x minus 8. Divide both sides by 2 right here. I get 2x plus 5 because that one is reduced. And 8 divided by 2 is 4. There's your final answer. What multiplies to give me negative 36 but adds to give me negative 9? Again, I've thought about these, gone through them. I get 3 and negative 12. So I get x plus 3, x minus 12. But divide by 2. 3 over 2 doesn't reduce, so I slide the 2 up. 12 over 2 reduces, so I get minus 6. Number 13. What multiplies to give me 72, but adds to give me negative 19? So I go through my list. I say 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 doesn't work, 6 and 12, 7 doesn't work, 8 and 9. Those are all the things that multiply to give me 72. Signs are the same and they're both negative. So all of these would be both negatives. And if I go through and do the sum, I know it's not that, I know it's not that, I know it's not that. 18 plus 4 is not 19. 6 and 12 is negative 18, so that's not 19. And 8 and 9 doesn't make 19. So since none of these integers work, we write prime. When you can't find an integer factors, then the trinomial is prime. Okay, number 14. What multiplies to give you 49, but adds to give you negative 14? I know that is negative 7 and negative 7. So I get x minus 7, x minus 7. There's no coefficient to divide out, so I'm done. Just put it as a square. Number 15, what multiplies to give me 36, but adds to give me 12? Signs are the same, they're both positive. So again, I come up with 6 and 6. That's going to be x plus 6, x plus 6. Divide by 4 and reduce. 6/4 reduces to 3 over 2. Don't leave it as a fraction. Swing those out. You get 2x plus 3, 2x plus 3. And in the end, we would just write it as 2x plus 3 squared. Okay, example 16 is a special case. We call this a difference, meaning subtraction, of squares. I have a square here and a square here. X squared is a square, and 144 is the square of what number? Okay, it is the square of 12. So, the difference of squares. I can do it the exact same way. I say what multiplies to give me negative 144, but adds to give me 0. Signs are different. And you would come up with positive 12 and negative 12. That would be what would give me 0. So if I write it as x plus 12, x minus 12, then that is your fast and easy difference of squares. You just do the square root of this and the square root of this, and then do plus minus sign. Plus minus. So if I recognize example 17, automatically is a difference of squares. In other words, a square, perfect square, minus a perfect square. Then I can go ahead and write those down. What is the square root of 9x squared? That would be 3x. I'm just going to go on both. And then 16. What's the square root of 16? 4. And make sure you put plus, minus. Signs are different. And that's your difference of squares. So, is this a difference of squares? It is. What is x to the 4th, the square of? how would you get x to the fourth? The square root of x to the fourth is x squared. And then what's the square root of 81? You get 9. And just like I said up here, you want to make sure you put plus in one and minus in the other. Am I finished with that problem? I'm not. Here's why I'm not finished. If I look over here, x squared minus 9 is also a difference of squares. Now, we have no such property that is a sum of squares. This right here, this piece right here is already factored as far as it can go. But this one we can factor further. So let's go ahead and write down our first factor of x squared plus 9. And now, how do I factor x squared minus 9? So what's the square root of x squared? X. And what's the square root of 9? 3. Again, plus in one, minus in the other. And that's your final answer for number 18. Go ahead and get started on the practice.